Hi, this is Mrs. Marita. Welcome to Section 8.2, Graphing a Quadratic Function. Please turn your student companion book to page 172, and let's begin by taking some notes in the margin. Today we're focusing on graphing quadratic functions. A quadratic function can be written in the form f of x is equal to a times the quantity x minus h squared plus k. Let's look at how a, h, and k affect our graph. The value of a in front of the parentheses is going to tell us if our graph stretches and gets skinnier, or shrinks and gets wider, or if our function is going to flip, if the graph will flip and open down. If your a is greater than 1, then your graph is going to have a vertical stretch. You're going to pull it up and it's going to get thinner. If a is between 0 and 1, then you're going to have a vertical shrink. It's like you're pushing down the graph and it's getting wider. And then last, if a is less than 0, you're going to flip your graph or reflect it. So instead of opening up, your graph will open down. Just a recall from our last lesson in 8.1, all of the graphs that are quadratics are going to be a parabola, so that U shape. And we know we'll have a quadratic function if we have a quantity squared. That x minus h quantity squared tells us we have a quadratic function. And then the h and k are going to help us with our horizontal and vertical shifts. H will give us our horizontal shift, so either left or right, and K will give us our vertical shift, either up or down. Last, to help us with our graph, our vertex will always be the point H, K. And our axis of symmetry will go right down the middle. That'll be your x equals h line. In our last lesson in section 8.1, we focused a lot on the value of a and how that affected our graph. Today we're going to focus more on h and k. Let's look at example 1 to understand better the graph of g of x equal to x squared plus k. Example 1, part A. Now we're given h of x is equal to x squared plus 3, and we want to compare this graph with the parent function f of x equal to just x squared. Let's start by plotting 5 points that correspond to our parent function f of x equal to x squared. Our first point, the vertex, is at 0, 0. In this example, our h is 0 and our k is 0. That's the f of x function we're talking about. And then if you plug in positive 1, 1 squared gives us 1. So we get our first point to the right, 1, 1. If you plugged in negative 1 squared, we'd get negative 1 times negative 1, so also positive 1. And that's our first point to the left. Similarly, if we plugged in 2 and negative 2, we get the two final points, those highest points, at 2, positive 4, and negative 2, positive 4. Now do your best to connect those dots and make that parabola shape, that U shape. Remember, this is our parent function. F of x is equal to x squared. Now we want to graph our new function, h of x, and then we can describe how this changes from our parent function. In this example, our k is equal to positive 3. K is giving us a vertical shift. So this tells us we need to shift the graph up 3 units. So each of these points is going to shift up 3 units. So from the vertex, we're going to go up 1, 2, 3. This will be my new vertex. And then from my first point to the right, we'll go up 1, 2, 3. And 1, 2, 3 on the left. And this is a little off of the graph. 1, 2, 3 would be about up here and about up here. Again, connect your points and make that U shape the best you can. If you have 2 colors or a highlighter, you can use that for your notes here. Or another way that you can emphasize the 2 graphs is by doing a solid and a dashed line. So maybe your parent function is a dashed line, and then your final answer, the h of x, is a solid line. Try part B on your own, and then we'll check. Did you get this one right? In example B, we have the function j of x is equal to x squared minus 2. The k in this example is negative 2, so we're going to shift all of our points down 2 units. Now on to example 2. For example 2, we're going to examine the shifting with our value for h. With k on the outside, we shift it up and down, and so with our h inside the parentheses, this is going to be our left and right shift. Just a reminder, like your absolute value, if we have a function like part A, h of x is equal to the quantity x plus 1 squared, we're actually going to have an h equal to -1. Let's look at part A. So for part A, we have our x plus 1 squared, or we could visualize this as x minus a -1 squared. Remember, with our parent function, we have that built-in negative. So in this example, our h is equal to -1, and so for our graph, we're going to shift all of our points left 1 unit. Our purple graph is the same parent function that we saw before. Now let's do our transformed graph, h of x. So for number 2, part A, how does the graph of each function compare to the graph of f of x equal to x squared? F of x squared is my purple graph, h of x is my red graph, and so we can see that the red graph was shifted 1 unit to the left. Try part B on your own, and then we'll check. So for part B, our h was equal to +5, and so we shifted all of our points to the right 5 units. So our new vertex is at the point 5, 0. Our red graph corresponds to this j of x function, x minus 5 squared, and the purple graph is still the just plain old x squared, the parent function. All right, last example, example 3, and this puts it all together. We have an a, an h, and a k for our function f of x. In this example, we want to know, how does the graph of f of x equal to -3 times the quantity x minus 5 squared plus 7 compared to the graph of the parent function? Remember, your parent function is always just the basic f of x equals x squared. We're going to do this problem in 3 parts. First, we'll look at the a, and then we'll look at the h, and then we'll look at the k. So we're going to look at 3 different transformations. But first, let's graph our parent function. Take a moment to set up your axes and graph your parent function, the f of x equal to x squared. I'm going to graph this parent function just with the dotted line to emphasize this is not my final answer. From now on, I'm just going to graph my final answer with a solid line. First, let's look at the -3. So our a is equal to -3. This is going to provide a vertical stretch, so our graph will be thinner, and the negative tells us we need to reflect or flip across the x-axis. First, let's deal with the stretch. A vertical stretch and a reflection does not affect our vertex. We're not shifting left or right at all. So my vertex is still going to be at the origin, at 0, 0. But instead of looking at a function, f of x equal to x squared, now we're looking at a function, f of x is equal to 3x squared. So instead of graphing my next point at 1, 1, I'm going to graph my next point over 1 up 3. So you could work this out if you'd like by plugging in the value 1, and you get 3 times 1 squared, 3 times 1, we just get 3. And then our reflection would also be up 3. Next, we can look at our f of 2. We still have the 3 times 2 squared. So instead of going over 2 up 4, just that 2 squared, we're going to go over 2 up 12, 4 times 3. Now that's pretty far off my graph. Let's see, this is 3, 4, 5, 6. That's going to be up here somewhere. I'm just going to guesstimate. Now, those 5 points, that's just taking care of this stretch. See how the graph got stretched out? But I'm not even going to connect these yet because now we need to reflect. So I'm going to flip all of these points below the x-axis. 0, 0 stays here for my vertex, and so instead of going over 1 up 3, I'm going to go over 1 down 3, and then backwards 1 and down 3. And then again, way down here somewhere will be those other points. And then I'm going to do another, oops, little dashed graph just to emphasize, this is taking care, make sure that looks like a U, not a V. And so this is just taking care of that first transformation of the A. Now let's tackle our H. In this example, our H is going to be positive 5. Recall that built-in negative, so our H is positive 5. And this is going to tell us about our horizontal shift. So we're going to shift all of our points to the right, because our H is positive, to the right 5 units. So the first one we can move is the vertex. So we'll go over 1, 2, 3, 4, 5. Looks like we need a few more tick marks on this graph. There we go. And then again, we can move this point right here over 1, 2, 3, 4, 5. And then the last point over 5. Notice these 2 points should still be 1 to the right and 1 to the left of our vertex. And then 2 to the left, we have our point down here, and 2 to the right, way down here. Now, my scale is not perfect. I am not a computer. I don't expect you to be either, but these should look like they've got the same width. This is still a skinnier graph than the original. Last is our K. And in this example, whoa, this is going to get crazy. Let's make a little correction. Instead of a 7, would you guys change this to a 2? This is not going to fit on our graph. Let's make this one a 2. I'll make sure your graphs fit better when you do these for homework. And so let's say that our K is equal to 2. Make a little note, we changed this one. And so if our K is equal to 2, your K tells us about a vertical shift. And so we're going to need to shift up 2 units. Hey, where'd my number 5 go? That should be up there. So my last transformation is going to go up 1, 2 units, and up 1, 2 units, up 1, 2, and up about 2. Now this is my final answer, so I'm going to finish this one. Oops, I missed. You know what to do when you miss, make the point a little bigger. Okay. Whoa. This is tough for me on my tablet, but I'm getting better. I gotta practice to learn. Your final answer for the graph of f of x is equal to -3 times the quantity x minus 5 squared plus 2. Remember we changed that to a 2? My final answer is this graph right here. Now when you're doing these for homework, if this is helpful to do each piece individually, you absolutely can. Another strategy though would be to focus on the vertex. So just to wrap this one up, we know from the original equation that our vertex is going to be 5, 2. That's this point right here. This is 5, 2, the vertex. And then you can use your A, that -3 idea, to help you with the shifting. That might be a more advanced strategy. We can practice that in class some more. But either way, we do want to recognize our vertex is that point 5, 2. And that's it for section 8.2. Make sure you copy down all your notes and bring your questions to class.